in terms of boiling point of alcohols versus alkanes, because now we can start comparing different families, remember that, the boiling point of an alcohol is always going to be higher than the boiling point of its equivalent alkane. What I mean by that is methanol, equivalent of that is methane. Propanol, equivalent of that is propane. So it's the equivalent alkane with the same number of carbon atoms. Okay, so once again, whenever you're explaining properties, you always think of it in terms of intermolecular forces. So if the question is asking you, explain the difference in boiling point between an alcohol and an alkane, you're going to wonder to yourself, if the theory doesn't come to you straight away, you're going to wonder to yourself, what's the difference in intermolecular forces between the two? You're going to look at the formulas and you're going to notice that the alcohol has an OH while the alkane doesn't. So that's the point of difference, and that's going to explain your difference in your answer. The boiling point of an alcohol is bigger than the boiling point of your alkane because alkanes are non-polar. They don't have any electronegative atom inside of it. Okay, alkanes are only composed of carbon and hydrogen, so it's non-polar, which means the only kind of force that it can form is your weak dispersion force. Okay, if you require revision on polarity and intermolecular forces, come have a chat with me. We can talk to you about getting the Year 11 Module 1 notes, which they've finished by now, by the way. Year 11 is up to, they're starting limiting reagent today. Oh, sorry, not today. Today is already 7 o'clock. They're starting limiting reagents on Saturday. So I don't know if you guys remember limiting reagents when you guys did it, but I introduced it to them briefly last lesson, and I shouldn't have done that because they left with a bit of confusion. I should have just started it this Saturday. But anyway, okay, hopefully we clarify it for them. But if you need notes, extra notes on your intermolecular forces and your polarity, come have a talk to me. We can get that sorted out for you. Okay, but alkanes, non-polar, weak dispersion forces, those are the weakest type of intermolecular forces. So because it's the weakest type, you don't require as much energy to break it, which means alkanes have really low boiling points. Alcohols, on the other hand, they have your hydroxyl functional group, which means they can form hydrogen bonding forces. Now, hydrogen bonding forces is between hydrogen and 3 different types of elements. Hydrogen bonded to an oxygen is one of them, because now we're talking about alcohols with your OH. My question is, do you guys remember the 2 other elements that hydrogen's bonded to cause hydrogen bonding forces? So hydrogen bonding forces forms when hydrogen bonds to an O. What are the other 2 elements that it can bond to?
Isn't it like fluorine or something?
Fluorine, good. Fluorine's one of them. What's the last one? This is a bit of a memory test.
Yeah.
I'll give you a hint. It's to the left of oxygen in your periodic table. What's to the left of oxygen?
Nitrogen?
Yeah, nitrogen. Okay, so hydrogen bonding forces can form between, hydrogen bonding forces can exist between a molecule if that molecule has an OH, HF, or a HN bond inside of it. Okay, so when you go into your amines and your amides later on, have this in mind, pop this down. This is revision from year 11, guys, but you weren't with me in year 11, but if you were, then I would have told you to please keep this in your head because you do need it for year 12, okay? It's the biggest shock to me because you know how students are always saying, oh, this kind of stuff doesn't relate anymore, I can forget about it later. And that's my technique in university. I've been forgetting about it later and it keeps coming back. Okay, so in year 11 and year 12, you can get away with it because we like to do quite a bit of revision, but just a tip for when you guys go into university and say goodbye to me, keep your notes up until you graduate, because I would like to get mine back because they're constantly asking stuff that builds on from each other. Okay, so in year 11, 12, you might not appreciate it so much, but just as proof to you, it does come back, and in university, it certainly does come back. Okay, so thank me later for that one. But yes, your hydrogen bonding force is between hydrogen, oxygen, hydrogen, fluorine, and hydrogen, nitrogen. So fluorine isn't something we'll see so often, but nitrogen you'll see when you go into your amines and your amides. Okay, but hydrogen bonding forces is a type of dipole-dipole force, by the way. Hydrogen bonding forces is the strongest type of, is the strongest type of intermolecular force, which means it requires the most amount of energy to break out of the 3 different types of intermolecular forces. If it requires the most amount of energy to break, you need to boil it at a higher temperature. You need to increase the temperature more before it can start boiling. So that's why alcohols have a higher boiling point. Okay, can you guys give me a thumbs up if this makes sense as well? Alcohols versus alkanes. Alkanes only have weak dispersion forces. Alcohols have hydrogen bonding forces, which require more energy, so therefore higher boiling point.